are working. Hello. Two screens are on. Okay. Okay, before I start, I just want to tell you, because in the previous class I told you to please go through the derivatives and integration part that you studied in your maybe school. So in this book, there are some formulas are given in the very first page. In the very first page, some formulas are given related to the derivatives and integrations, right? So I will suggest please go through them. It will revise your mind, okay? So that it will help you to do or to solve the problem faster. Okay, just one page. One column is for derivatives and one column for the integration. The very first page of this book. Okay? Clear? Are you getting me? Hello, you? No, I'm asking you. You look little surprised. Did you get what I said? I just told you, because we are going to solve ordinary differential equation, and to solve these equations we need to encounter multiple problems related to derivatives and integration. Okay, so for that, because you guys have studied this derivatives integration when you were in the school, possibly, right? So I will suggest please revise them. That is available in the very first page of the book, and this book is also available online, so please go through it. I already know what is differential equation, what is engineering mathematics, why we are studying engineering mathematics, and specifically our focus is ordinary differential equation, right? So, and I also told you that we may encounter, these are the 4 different types of problem we may encounter in the process. One is solve the ordinary differential equation, where we try to find out the general solution or the generic solution. And the next one is the initial value problem, where we will try to find out the particular solution. And then we have the next one is boundary value problem, where we will have some limit, that means this should be the minimum, this should be the maximum. So based on that, the value will be decided. And the final one is the verification of solution. Okay. So what I will do in today's class, since we have not studied in detail about the ordinary differential, I will try to initiate the class by solving very simple ordinary differential equation, so that you can have some kind of feeling that what exactly the ordinary differential equation and how we should start solving. And we may encounter different types of ordinary differential equation, and to solve them, maybe we cannot solve them in one way. There are different problems can be solved by different methods. Okay, so when we will study, we can discuss them in detail. So first, today's class we will start with very simple problem. Suppose it is like solve the ODE, ordinary differential equation. So our focus in today's class is this: solve the ordinary differential equation. Okay. So I'm not going to discuss about come. So I'm not going to specify any kind of method. We'll just try to apply some kind of random solution to solve the problem, right? So that is our today's class. So let's start. If I will start writing, the very first problem is, it is given y dash is equal to minus sine pi x. This is the ODE. This is the ordinary differential equation. Okay? So we want to solve this ordinary differential equation. So can you tell me, when I'm saying that we want to solve the ordinary differential equation means what? What exactly we want to find out? Y, because y is the unknown function here. Okay. So how to solve this one? So I believe some of you have this idea why this I have written y dash, right? It's the first derivative of y, right? That means this is dy by dx, right? And here I have minus sine pi x. Okay, so how to solve this one? What I will do is dy is equal to minus sine pi x, and I will take the dx to this side. And then what I will do, apply integration both sides. So that means when I apply integration both sides, it will be dy integration minus sine pi x dx, and here I apply the integration. So what I will get here, I will get y and then sine pi x integration. Anybody remember? What is the integration of sine x? Yes? Say louder. Cosine x? What? Cosine x? Only cosine x? Or negative cosine x? Yeah. So that means for sine x it is negative cosine x, so minus minus become plus, so I can simply write cosine x, so actually it is pi x, so it is become pi cosine x, and we have to divide the pi here, and with that we can add a constant. Right? It's a very simple one. Okay, so let's try another question. So write the next question, y dash is equal to e to the power minus 3x Yeah, don't get confused. Sometimes I write y like this, sometimes I write y like that. Okay, it's all set. Okay, don't get confused. So this, how to proceed? This is dy by dx, right, is equal to e to the power minus 3x, and then I can take the dx to other side. This is dy is equal to e to the power minus 3x, and here we have the dx, right? And then in the next step I will apply the integration both sides. Yes, if I will apply the integration, how much I will get? Yeah, somebody can tell me the answer? I believe most of you know about this. So this is y is equal to e to the power minus 3x by minus 3 plus constant. Am I right? Integration of e to the power x is same e to the power x, right? 3x by 3 minus 3 to the power minus 3x, sorry, e to the power minus 3x means e to the power minus 3x by minus 3, right? So this is how we got, this is the solution. I believe all of you are following me, because these are very trivial questions. We are not going to deal with any difficult one. Okay, so let's try another one. All okay? Okay. So let's try another one. Question number 3. Y dash is equal to do you remember this one? Yes. Oh. I don't know what is the permanent solution, because I change, I buy a new one, still I'm getting the same problem. Yeah. Yeah. Remember this one? Okay. So then tell me, what is the solution in this case? This is dy by dx is equal to cos 4x, and then you can change it to dy is equal to cos 4x dx, right? Then I can apply the integration here. Right? So what is the solution? Yes? Yes, sin hyperbolic h 4x then by 4 plus constant. Okay, so little bit familiar about these things. Okay, so let's try a little bit difficult question. Okay. Maybe I will write another one. Question number 4. Y dash is equal to x into e to the power x square by 2. X into e to the power x square by 2. Okay, don't get confused. Yeah, that's a little bit tricky. Okay, so how to solve this one? Anyone can try?
Integration by part.
Yes?
Integration by part.
Equation by parts? No, we should not go by so difficult. Let's try some simple method. Okay, we will come to this equation by parts, all those things. I'm just refreshing your mind about derivatives, integration, all those things. Okay, so let's try a very simple method. This is dy by dx is equal to x e to the power x square by 2. So that means our dy is equal to x e to the power x square by 2 into dx. So this is where we stay. Okay. So let's put something. If I will specifically mention, let some value t is equal to x square by 2. Okay, let x square by 2 is equal to t. Okay, let's assume that one. Okay, then tell me what is dt by dx? dt by dx is equal to x. Yes. Then your dt is equal to x dx. So if you clearly see two things, one is this one, dt is equal to x dx, another one is t is equal to x square by 2. So if we try to put these two here, then our this problem now become dy is equal to how much? E to the power t dt. Right? So simple. Then what to do? Solve this one. Apply integration. When we apply integration, we will get y is equal to how much? E to the power t plus constant. Right? But this is not our solution, because our question is on x, but we got the solution in t. So let's change it. So what to do? Just put what is the value of t? That is e to the that is e to the power x square by 2 plus c. So that is my answer. Right? Simple. Okay. Let's try another one. Yeah, if somebody is missing something, let me know, okay? But still, we are recording, we will upload it. Okay, so don't worry about if you miss something or something you do not understand, you can still go through the video to refresh it. Right? Now, the next question. Question number 5. Okay. If I will take a simple question, another one. Y dash is equal to y. Y dash is equal to y. How to solve this one? That implies I can say dy by dx is equal to y. That implies I can keep all the y one side, all the x other side. What I can do that dy by y is equal to dx, and then apply the integration. If I apply the integration here, how much I will get? Yes, dy by dx. Sorry, dy by y integration is how much? Anybody remember? No? So do you remember this one? Hello. This one is equal to x plus c. Right? But our answer is supposed to be what is y? This is ln y. Let's change it. Simple, apply mathematics. That implies my y will be e to the power x plus c. That means I can write e to the power x into e to the power c, which I can further write some constant c1 e to the power x. Yes? Any confusion? Now, all these problems we try to solve now are what kind of problems? ODs, and we try to find out the generic solution or the general solution of the problem. Yes or no? All are general solutions. All are general solutions. Okay? So, let's try something different, because if you remember, as I mentioned before, we are going to encounter different types of problem. One is the general solution, which we solve. 4-5 problem we check. Let's try one which is coming under the category of initial value problem. Okay, one initial value problem where our objective is to find out the particular solution. Let's try just simple one question on okay. Let's try one problem coming under the category of initial value problem. So later on I will start writing initial value problem is IVP. Okay, that stands for initial value problem. Okay. Okay, so here the question will be in this form. So this is question number, let's say 6. The question is y dash is equal to 3y, and the initial condition is given y0 is equal to 5.7. So let's categorize which part is what. So this one is the given OD we want to solve, and this one is the initial value given. Okay, and we want to solve this one, and our objective is to find out the particular solution. So before getting the particular solution, first we need to find out the general solution or the generic solution. After getting the generic solution, we need to find out the particular solution, right? So to find out the general solution or the generic solution, what is the first step? Solve the OD. Okay, so let's solve this OD. That is y dash is equal to 3y. That means it is dy by dx is equal to 3y, right? Then the next thing is dy by y is equal to 3 dx. I bring the y to the left, took the dx to the right. Okay, and then my job is very simple. I just apply the integration both sides. Okay, so when I apply the integration both sides, can you tell me what should I get? Because previous problem was quite similar. Yes, ln y is equal to, yes, 3x plus c, right? 3x plus c. Is it making sense? Okay. Then what is my next step? I need to find out the general solution. That is y is equal to how much? The constant c e to the power 3x. Yes. So this one is my general solution. This one is my general solution. Now I have to put the initial values in the general solution. That means when I am saying the initial value is y0, when I say y0 is equal to 5.7, what does it mean? That means when x is equal to 0, y is equal to 5.7. That is the initial condition. When x is 0, y is equal to 5.7. That is the initial condition. So what I need to do is I just need to put these initial values in the general solution. Right? So when I will put the initial values in the general solution, so how much I will get? I will get y in place of y, I can write 5.7 is equal to 0. In place of y, I write 5.7. Right? Now, what I will get? From here, I will get what?
C equals 5.7.
Yes, C equal to 5.7. I find out the value of the constant. Now I just need to put this constant value in the general solution. That will be my particular solution. That means now the particular solution what is y is equal to 5.7 into e to the power 3x. So this is my particular solution. Right? Okay. So we saw one example, some example for the general solution, some example for the particular solution. For the timing, skipping the boundary value because we will come to the boundary value later part of the course. One thing is left is the verification of the solution because I mentioned 4 things: general solution, particular solution, boundary value solution, and the last one, verification of the solution. Okay, so let's little bit discuss about the verification of solution with one example. What is the permanent solution to this problem? Okay, so let's try to solve. Okay, so here is the question here. Question number 7. So let's say it is verification. Okay, so here is, so this is, let's say, question number 7. Here is the ODE, given ODE is y double dash is equal to minus y. Okay, so this is the OD, and the solution given to this is here. Y is equal to A sin x plus B cosine x. Let's say this is the solution and this is the problem. This is the given OD and this is the solution to the OD. Okay, it is given. Our job, let's say, check that whether this one is a valid solution or not. Okay, so when we try to solve, we just need to apply it. Either we can go from the left hand side or the right hand side, because that is how the solution proof is actually done. So we have the y. So what we need to find out? Y double dash from this y. Okay, so y is given. So this is my y. So what will be my y dash? Yes. What is my y dash? Just the derivative of y. What should it be? Come on. This one I will not solve. You have to tell me so that I can write. A. Yes. Cosine x plus, right, or minus? Minus b cosine x. Oh, sin x, right. Sin x. Then what is my y dash? Y double dash? Yes? Because we have to find out the derivative of y dash. Yes or no? What is the derivative of y dash? That means we have to find out the derivative of this particular one. Then what should be? Yes, minus a sin x, yes, minus b cosine x. Now if I will clearly take the minus common, it will be a sin x plus b cosine x. Yes, what exactly it is? Minus y. Yeah, so this is nothing but y. That means it proved that this is the original solution to this problem. Yeah, he found the class is so boring, he is sleeping comfortably. Look at it. Yeah, the guy behind you. Hello? Are you okay? Are you guys finding it interesting?
Yes.
Okay. But he's sleeping, means he's find it boring. Okay, so let's try one more question and how to say let's try this question. Y dash plus 5xy is equal to 0. And the initial condition is given y0 is equal to I. Yes. Can you solve this one? So how to solve this one? First thing, start writing in the proper format. That means this is y dash is equal to minus 5x y. Wait. Then we try to separate the y one side and the x on the other side. That means I will just write dy by dx is equal to minus 5xy, and in the next step what I will do, dy by y is equal to minus 5x dx, and then I just apply the integration both sides. Apply the integration. I will get ln y is equal to minus, yeah, how much? 5. How much? Power by 2 plus constant. So if I will try to solve this one, I will get y is equal to how much? Constant c into e to the power minus 2.5 x square. So this is my general solution. Yes. and confusion. I directly wrote the, without going step by step, I directly wrote the solution. Is this okay? Okay, very good. Because you cannot. Are they from your class? Okay, so this is what kind of solution? General. We need to find out the particular one. That means when x is equal to 0, y is equal to pi. So let's put the same value. It is pi is equal to c e to the power minus 2.5 into 0. That gives us c is equal to pi. Then what is my particular solution? Y is equal to pi e to the power minus 2.5 x squared. Making sense? Okay, so we will stop here, and in the next class we will try some application oriented problem, 2-3 application oriented problem, and then we will move to the first method of the ODE, that is the Euler. Okay, so yeah, we will stop here. Thank you very much.